about the project title Hard Disk Failure Prediction. Hard disks are the primary and most important storage devices used in the computers today, and many data centers rely on the large number of hard disks to store vital information. With the rapid development of the internet and cloud platforms, the storage and pre-processing of the massive data has brought several challenges to the relevant personal and storage systems. A small hard disk failure will cause a significant amount of data loss, thus causing economic losses. To reduce this situation, self-monitoring analysis and reporting technology was developed in the 1990s, led by Compaq and developed in collaboration with several hard disk manufacturers. This new technology detects all kinds of working information inside the hard disk, such as the number of hard disk reads and writes, the number of heads, loads and unloads, the seek error rate, and the current ambient temperature of the hard disk, and writes them to the specified register through binary code. These attribute values are usually updated once a day. According to this attribute value, user can compare them with the threshold specified by various manufacturers so that they can take measures to deal with the failures in advance. Some hard disks can even alarm themselves to remind users to back up data to reduce losses. In an ideal state, as long as some attribute values of the hard disk do not exceed the threshold and are within a reasonable range, the hard disk will not have any problem. The main objective of this problem statement is to predict hard disk failure based upon the algorithms random forest decision tree, logistic regression, support vector machine, and gradient boosting algorithm. Hardware requirements: we need operating system, Windows only processor, i5 and above, RAM 4 GB and above, hard disk 20 GB and above. Coming to the software requirements, we need to install Python with a version of 3.7. Methodologies: to implement this project, we have designed few modules. First one, upload hard disk dataset. Using this module, we will upload the dataset to this application and then read all records from the dataset. Second one, pre-processing dataset module. By this module, we will read empty and missing values from the dataset and then replace with 0. Third module, generate, train and test dataset. Using this module, we will divide or split the dataset into train and test, where applications used 80% of dataset for training machine learning algorithm models and used 20% of dataset to test trained model. Trained model will apply on test dataset to predict classes labels, and then classes will be compared with the original dataset to calculate accuracy. Then fourth model, that is random forest algorithm. Using this module, we will train random forest algorithm with the above dataset and then calculate the accuracy. Fifth module, run decision tree algorithm. Using this module, we will train decision tree algorithm with the above dataset and then calculate accuracy. Sixth module, run logistic regression algorithm. Using this module, we will train logistic regression algorithm with the above dataset and then calculate accuracy. Not only these three algorithms, which also we will be including support vector machine algorithm and gradient boosting algorithm in this project. We will train them and also we will calculate accuracy based upon the test dataset. Last module, that is comparison graph. By this module, we will plot accuracy, precision, recall and F1 score comparison graph of all the algorithms. Next, execution. Coming to the execution, close this file and open the code file. This is the code file, consists of dataset which contains the file of hard disk folder, and then in this code particularly we are having two codes, that is hard disk failure 1 and hard disk failure 2. in hard disk failure 1, we are going to train up with random forest, logistic regression and decision tree algorithm. And in hard disk failure 2 code, we are going to train with the algorithm support vector machine and gas gradient boosting algorithm. So now for this is the these are the main code files and this is the run bat file. This run bat file, instead of executing the program in command line interface, we created Windows bat file to execute the project. So by clicking double tap, first we will execute the hard disk failure 1 and next we will execute the hard disk failure 2. So for executing hard disk failure 1 code, run hard disk failure 1 button. So by clicking this file, by clicking that file double tap, we are going to graphical user interface which is interactive with the program user. First one button, upload hard disk. By clicking this button, it leads to the dialog box open and select the dataset and click on open. The dataset will be loaded and it will read and generate the attributes of the dataset. Then next button, pre-processing dataset. By clicking this button, it will pre-process the dataset and replaces the null value with a 0 and it will show the graphical representation as x-axis which indicates the categories of class dataset, that is healthy hard disk and failure hard disk. In the y-axis, we can indicate the count of the classes found in the dataset. Now close this graph and you can see the variables which we have extracted. And the next button, generate, train and test dataset. By clicking this button, the dataset complete records will be divided into 20% for the test data and 80% for the train data. The next one, run random forest algorithm. By clicking this button, the button will be generated confusion matrix of random forest algorithm with the predicted class and also it will show the true class values. Healthy, how many are there and how many it was predicted correctly, and failed, how many are predicted correctly. So by this you can check that healthy, true classes and predict classes of the random forest algorithm. Now close this graph and go to the graphical user interface. It indicates the random forest accuracy score, precision score and recall score. Now go to the next button, that is run decision tree algorithm. By clicking this button, it will be leading into the decision tree confusion matrix graphical interface. This is the true classes predicted value count and x-axis indicates the predicted class. Then close this confusion matrix graphical representation and you can see the accuracy score of decision tree algorithm. The next button, run logistic regression algorithm. By clicking this button, it will show the confusion matrix of the true classes and predicted classes based upon the healthy and failed hard disk dataset of the logistic regression. And close this graph and go to the graphical user interface. It leads to the accuracy level of logistic regressions. Now next button, comparison graph. By clicking this button, it will show the comparison of the three algorithms. Here you can see that random forest and decision tree are predicting the equal percentage of accuracy. So now close this one and exit the code. We are executed the first code. Now we are going to execute the second code. Same process, double tap, it leads to the graphical user interface and we have to click the buttons and select it. So first button, upload dataset. So by clicking that button, dialog box open and select the dataset and click on the open. Dataset will be loaded and it will be generate the attributes found in the dataset. Next one, pre-processing dataset. By clicking this button, it will leads to the pre-process and we will be replacing the missing values with the 0 and graphical representation with the classes divided and also count of the classes which are found in the dataset. Now close this graph and next button, generate, train and test dataset. By clicking this button, that complete dataset records are divided into training part 80% of data and testing part 20% of the data. Now next button, run random forest algorithm. By clicking this button, it will generate confusion matrix of the graphical representation of random forest, predicted classes and the true classes count. Now close this graph and in the graphical user interface, it will be showing the accuracy of random forest algorithm. Then next one, run support vector machine algorithm. This support vector machine algorithm also will generate the confusion matrix and also the accuracy score. So description of support vector machine are one of the most popular supervised learning algorithm which is used for classification as well as regression problems. However, primarily it is used for classification problems in machine learning. The goal of support vector algorithm is to create the best line or decision boundary that can be segregated n-dimensional space into classes so that we can easily put the new data point in the correct category in the future. This best decision boundary is called as hyperplane. Support vector machine chooses the extreme points or vectors that help in creating the hyperplane. These extreme cases are called as support vectors, and then hence algorithm is termed as support vector machine. So now you can see on the screen that is support vector machine confusion matrix which was predicted in the graphical representation with the predicted classes and also the true classes. And now close this file and you can see the accuracy of support vector machine accuracy. Now click on run gradient boosting algorithm. This gradient boosting algorithm is powerful boosting algorithm that combines several weak learners into strong learners, in which each new model is trained to minimize the loss function such as mean score error or cross entropy of the previous model using gradient descent. In each iteration, the algorithm computes the gradient of the loss function with respect to the prediction of the current assemble and then train a new weak model to minimize this gradient. The predictions of new model are then added to the assemble and this process is repeated until a stopping criteria is met. So this is the basic introduction of the gradient boosting and algorithm. Now here you can on the screen you can see the gradient boosting confusion metric. So it is predicted with the predicted classes and also true classes. Now close this graph and on the graphical user interface you can see the accuracy of gradient boosting algorithm. Now see the comparison graph. By clicking this button you can see the comparison graph. So comparing this graph with the first code that is hard disk failure 1, there also we can see random forest is highest and here also in the graphical representation we can see random forest is highest. So now exit the code, complete code and go to the conclusion. So based upon the what project we have coded, that is based upon the prediction of hard disk failure prediction models based upon the classifications and regression trees, comparing with the state of the art model, the back propagation artificial neural network model, our classification is mainly focused on the random forest model that predicts best performance in the prediction of this project hard disk failure prediction as well as stability and interpretability. So by this concluding that hard disk failure prediction model project has the best accuracy result on the random forest algorithm.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.